This video is over lessons 41 through 43. Lesson 41, finding a percent of a number. Lesson 42, renaming fractions by multiplying by 1. And lesson 43, equivalent division problems and finding unknowns in fraction and decimal problems. Please take a moment to copy the title down into your notes. Hit play when you're ready to move on. Moving on in 3, 2, 1. To find a percent of a number, we have two things that we need to take care of. We need to take care of the of and the percent sign. So let's do an example. Let's find 56% of 34. Once again, we need to take care of the of and the percent sign. It doesn't really matter which we do first so long as we take care of both. So we're going to call option 1 taking care of the of first. So of means to multiply. So this means 56% times 34. Now I'm going to do a little bit of scratch work here. So 56 times 34. 4 times 6 is 24. Carry the 2. 4 times 5 is 20, plus 2 is 22. 0 down as a placeholder. 3 times 6 is 18. Carry the 1. 3 times 5 is 15, plus 1 is 16. Now we add. 4 and 0 makes 4. 2 and 8 makes 10. Carry the 1. 1 and 2 is 3, plus 9 is, plus 6 is 9. And then we've got a 1. So, this is 1,904, but because we haven't done anything with the percent sign, it tags along to the answer. Now we're going to take advantage of that rule that we learned earlier in a different video, that you can always replace something with what it's the same as. So I'm going to replace this percent sign with what it's the same as. So I still have a 1,904, but percent means divide by 100. Well, easiest way to divide by 100 here is going to remember that you can move the decimal twice. On a whole number, the decimal is usually is at the end, so if I move it 2 times, that would make the answer 19.04. Moving on in 3, 2, 1. Whereas option 1 was about using the of first, option 2, we're going to use up the percent sign first by changing the percentage to a decimal. So let's go ahead and do that same example again. But this time I'm going to take care of the percent sign first. So I'm going to kind of keep it separate a little bit. So I'm going to create a secondary problem down below to take care of the percent. And then when I'm all done, I'll take that answer and plug it back in up here. So 56%, well, percent means divide by 100. Move the decimal 2 times, 0.56. So that means that 56% is the same as 0.56. So up here, we're going to rewrite this problem now though, but I'm going to replace 56% with what it's the same as. 0.56. Of means times, and I've got my 34 still. Well, do what that says. We've got our answer. So 0.56 times 34 is going to be multiplied just like a whole number. So 4 times 6 is 24, carry the 2. 4 times 5 is 20, plus 2 is 22. I'm going to ignore that 0 because if it was a whole number, it wouldn't be there. 0 down as a placeholder. 3 times 6 is 18, carry the 1. 3 times 5 is 15, plus 1 is 16. Add it up. 4 and 0 makes 4. 8 and 2 makes 10, carry the 1. 1, 2, and 6 makes 9, and then I've got a 1. So, but remember that since this has 2 decimal places, and this has none, that means my answer needs to have a grand total of 1, 2 decimal places. So the answer is 19.04, which of course matches what we got in option 1. Moving on in 3, 2, 1. Option 3 is the option that I recommend the least, but every once in a while it may actually be the best one, just not as often as the other two. So let's go ahead and tackle that problem one more time. And like option 2, we're going to be taking care of the percent first. The difference being we're going to change it to a fraction. So again, I'm going to do a little side problem down here where I change 56% into what it means. Well, it means 56% means divide by 100. This time, to get a fraction, I'm going to take advantage of the fact that division means fractions. So I can take this and put 56 on top and 100 on bottom. Now I can reduce the fraction here, or I can wait till I'm at the end. It doesn't really matter. I'm going to go ahead and wait till the end to reduce. So now, if we come back up here, I know that 56% is really 56 hundredths. Of means times, and I'm going to go ahead and take advantage of 34 being the same as 34 over 1. So now I've got a fraction times a fraction. And so we multiply. And lo and behold, once again, we have 56 times 34. Which, if we look back at the other problems, for the sake of speed, we know is going to come out as 1,904. So, my numerator is 1,904 over my denominator, which is 100 times 1, or just 100. This is an improper fraction, so I need to simplify it. Well, 100 goes into 1,904 19 times. And I know that because 100 goes into 900 9 times, and it goes into 1,000 10 times. Well, 10 and 9 makes 19. If I take that 1,000 off and the 900 off, I'm left with just 4. And of course the denominator stays the same. I can reduce this by 2 over 2. So this becomes 19 and 2/50. And that's my answer. Moving on in 3, 2, 1. In order to change the look of something in mathematics, we either have to replace it with what it's the same as, or a piece of it with what that piece is the same as, or we need to multiply or divide by a form of 1. This is particularly helpful when we need to rename fractions. So, if I have a fraction like 5/6, I can rename it by multiplying by any form of 1 that I think would be useful. So if for some reason I thought it was useful to multiply by 7/7, the new fraction is going to be the same as 5/6. So 5 times 7 is 35, and 6 times 7 is 42. So 5/6 is the same as 35/42. This can be helpful on some problems where we may end up in a problem such as 3/8, and we may want to change this so that it becomes some number of 96. Well, in order to do this, I'm going to use a form of 1. So 9 times something is 96. Well, 9 times 12 is 96. This needs to be a form of 1, so if a 12 is on bottom, then on top I need a 12. If I finish this off now, 3 times 12 is 36. So it's 36/96. Moving on in 3, 2, 1. To create an equivalent division problem, first of all we need to remember that division means fractions. And when we have a fraction, we can multiply fractions by forms of 1 or divide by forms of 1 to rewrite them. So, if I have a problem like 75 divided by 15, I can use this to realize that if this was a fraction, it'd be 75/15, and I could reduce it. The point of creating equivalent division problems, though, is to make it easier to do, potentially even mental math. Now, the most obvious thing that I could divide both of these by is 5. We know 5 goes into 15 3 times, but not all of us have it memorized how many times 5 goes into 75. If you are one of those people who has it memorized, great, you can just move forward. But if not, we might want to look for something else. In fact, we might want to take advantage of the fact that 75 cents is 3/4. So we know that 3 goes into both of these. And that actually is going to be much easier. So if I divide 75 by 3, I get 25. And then if I divide 15 by 3, I get 5. Now I've created an equivalent division problem that's much easier to do. So, being an equivalent division problem means that the answer to this is also the answer to that. So 25 divided by 5 is 5. Therefore, 75 divided by 15 is also 5. Now, when you're working through equivalent division problems, do not reduce your divisor down to 1. It's not that it's going to give you the wrong answer, it's just that it's a lot of extra writing for no reason. For example, if we do this problem one more time, we're going to say, don't though. So if I had reduced this down to 25 divided by 5, and then I could have divided both of these by 5 again to get 5 divided by 1. Now this is another equivalent division problem, but over here, if I'm going to take this and divide by 5, why not just do the problem and be done? So yeah, 5 divided by 1 will give me the final answer of 5, just like before, but this was unnecessary. I could have just done this problem and gotten the answer. So if you're going to reduce by the divisor, don't bother. Just do the problem and be done. As a little reminder of what we've done here, now in blue, I'm going to add in divide by 5 here and divide by 5 here. Just to remind you that we divided both of those by 5. Let's do another problem now. 96 divided by 24. Well, it should be pretty obvious that I can divide both of these by 4. We obviously know that 4 goes into 24, but 96 is 4 less than 100. And we know 100 goes into, or 4 goes into 100, so 4 must also go into 96, since it's one group less. And since it is one group less, it must be 24 actually, because 25 groups of 4 is 100, so 24 groups of 4 must be 96. And then 24 divided by 4 is 6. We've now created an equivalent division problem. And this is much easier to solve. Now this is mental math. 24 divided by 6 would be 4. And there's my answer. I'm going to try out one last example. Let's try 5½ divided by 1/2. So when we're creating equivalent division problems, we don't have to just divide both numbers by the same thing. We can multiply both numbers by the same thing. So here, since we have fractions, it'd be much easier if we had whole numbers. So what I'm going to do is to change 1/2 into a whole number, I'm going to double it, or multiply it by 2. So I'm going to multiply both of these by 2, or double both of these. Well, when you double 5½ make sure you double both parts of it. So double 5 is 10, double 1/2 is 1, 10 and 1 makes 11. And now, if we double 1/2, we get 1. And this just became a lot easier. So the answer is 11. And we'll do one more quick one. Let's do 7 1/3 divided by 1/3. So this time with thirds, I want to turn them into whole numbers. So in order to turn a third into a whole, we have to triple it. In other words, we have to multiply it by 3. So I'm going to do the same thing over here. So if I triple 7 1/3, triple 7 is 21. Tripling a third is just 1. 21 and 1 makes 22. Tripling a third gives me 1. And again, a very easy problem. 22 divided by 1 is 22. Moving on in 3, 2, 1. To solve equations with fractions and decimals, we're going to follow the exact same steps that we have to solve equations with whole numbers. So for example, if we have 1/3 plus x equals 2/5, I'm going to start by copying the problem down. The second line of my work should be the line of the fact family that tells me how to solve it. In other words, the line of the fact family that tells me what equals x. So we're going to have to do some thinking, and I'm going to put that thinking in red. So 1/3 plus x equals 2/5. So think through the fact family. Well, in addition, we should know that the sum stays in the same spot. So 2/5 will stay where it is. That means that x and 1/3 trade places. In subtraction, I know that the sum becomes the minuend. So that means that for my next two problems, I'm going to have 2/5 minus something. And now I just fill in the other two numbers. And since they switch around, it doesn't matter which one goes where. So x and 1/3, 1/3, and x. Now remember, I'm looking for the one that tells me how to solve this. Well, if I do 2/5 minus 1/3, that answer will equal x. So that is the line of the fact family that I'm going to copy down. And now we need to do a little scratch work, which I'm going to put in blue here. So if I have 2/5 minus 1/3, I cannot subtract these because they do not have a common denominator. So I'm going to multiply them by forms of 1 to get a common denominator. So using multiplication, I want to change a 5 into something and a 3 into something so that these two somethings are the same. Well, I can turn them both into 15. So to turn a 5 into a 15, that would require me to multiply by 3. So this form of 1 will be 3/3. 2 times 3 is 6. And then on bottom, 5 times something is 15. Well, that's going to be 5. So this is 5/5. And 1 times 5 is 5. Now we're ready to subtract. So, excuse me, 6/15 minus 5/15 is 1/15. So there's my scratch work. Come back over here to the answer. X equals 1/15. So solving equations with fractions and decimals works the exact same way as before. We have to think through the fact family, and then we have to use the appropriate scratch work to get our answer. This video ends in 3, 2, 1.